Ready to fix some resource labels? I'm going here to show you how you can use Backstage together with Terraform to get your cloud resource labels under control and finally fix them. But before I start, I want to share a short story about resource labels. A couple of years ago, I was in a compliance audit. And who here knows what a compliance audit looks like or has been in one? Some. Yeah, the minority, lucky for the rest of you, so you don't want to be in one. But I brought a picture, so this is how they look like. And they're not fun and very serious. And the company I was working for just announced that compliance is the top priority of the year. And I was sitting there in this compliance audit. The auditor asked me, hey, you just completed your move to Azure, can you show the resources for this asset here? I said, sure, relabel everything. Yeah, so I started to type in the asset ID he mentioned, hit enter on the search in Azure, and something showed up, but not quite what I'd expected. A bunch of resources showed up related to the asset, some not related, but the worst part, most of them had descriptions like to do, NA, or I don't care about compliance, please set me. And then these auditors are like really mean, they don't give you any feedback, so I just looked down, took his notes. Okay, can we try another one? Yeah, okay, sure. Next one, typed in a new asset ID, hit enter, prayed to the tech gods, and nothing, nothing at all showed up this time. Why I'm telling you the story? Because resource labels are important. They are important for compliance, but also important to track ownership. If it's not for the auditors, it's for you, right? You want to know who owns what resource. And you want to be able to track costs for your services across your cloud. And this is only possible if you really have labels and good labels, up-to-date labels on every single cloud resource. And nowadays, it's also important to track your carbon footprint, especially for the company I work at. So I hope we are on the same page. Resource labels are important. Now, quick question here. Who uses Backstage? Yeah, good. I thought so. The majority, it's BackstageCon. But who uses Terraform together with Backstage? Oh, some, okay, nice. More than expected. The question is, do you use it to label your resources? And if so, why not? Wouldn't it be cool to take this Backstage entity here, this YAML file, with all of this nice, juicy metadata. You have an asset ID, you have the owner, you have the type, you have a life cycle, and you can put pretty much anything you want in there, right? You can add labels however you like. Isn't this the perfect blueprint for your labels? And then you take some module, spoiler, there will be some more infos about this soon, and you give it a component name, and you get labels. Wouldn't that be nice? And those labels are applied to your cloud resources. And if a team changes, on the next apply, it's swapped out. That's how labeling should be, right? Now, before I continue, short word about me. Hi, I'm Michael. I live south of Germany, near Munich. I like to go hiking with my family. And in my free time, I like to play D&D. And when I'm not impersonating an evil monster, I work as a senior platform engineer at 1,5. It's Europe's leading clean tech startup. It has been founded 4 years ago and already expanded to 7 countries. And there I work primarily with Google Cloud, Terramate, and Terraform, and a bunch of other stuff platform engineers do. Before that, I worked at Interp, a subsidiary of the ING. It's a large Hollandish bank, and you can probably guess where the compliance audit was. And there I worked with Azure, Spacelift, Kubernetes, and a bunch of other stuff. But both companies share one thing. In both companies, I introduced, implemented, and rolled out Backstage. And with Backstage, they also have one other thing in common. They're very different, right? One is compliance heavy and regulated banking environment. The other one, a clean tech startup, really fast growing. But both have one thing in common. They need resource labels. One for compliance reasons and ownership. The other one for ownership, cost, and carbon tracking. So I want to take you on a short story how we at 1,5 discovered how we can leverage Backstage to fix our resource labels. This is our cloud factory. This cloud factory is operated by the most trustworthy platform team you can imagine. And it produces neatly packaged cloud resources. And one day, someone comes along and says, man, we really need to track costs. We need to track CO2 emissions per team and resource. So the platform team says, yeah, sure, easy. We just need to label stuff. So Dave, poor Dave, is tasked with labeling the cloud resources. But he soon realizes, this can't go on like this. I can't do it anymore. I can't manually label every single Terraform resource of ours. We need to find some way of automating things. It's a platform team after all. So Dave and the others sit down together in the cafeteria and talk resource labels. And then soon they realize, hey, with Backstage is nice. Wouldn't it be cool to take all of this metadata? And they start discussing and idealizing and have plans and really work out a way to use Backstage. But what did they discuss? What did they find out? Why should they use Backstage for their resource labels? One word: metadata. Backstage has metadata, lots of it. That's the primary reason. But there's more. Backstage also provides us with this nice system model. And the system model can be used, or quick question here, who knows what the system model is? The Backstage system model? Okay, 1/3 about. Okay. It pretty much gives you some structure to organize your Backstage entities, and all of the catalog in Backstage is modeled after it. It has components. These are at the core of the catalog. And the components can be part of a system. And components also depend on resources. So resources are databases, for example, cloud resources, your Kubernetes cluster, things you need to run your component, your software. And every software, when it's not a library, needs some kind of resource. And the resources can also be part of a system. This is optional. So the team thought, wouldn't it be cool if we restructure our infrastructure based on the system model? This makes it easier to map the metadata and Backstage to our infrastructure. But what should we use? Should we use the system as our source of truth for the resource labels? It's too broad. And usually in Backstage, at least from my experience, the system doesn't really have rich metadata. It's a very broad category, and it's also not mandatory. So we can't really use the system as the source of truth for our metadata. We could use the resources. They're resources after all, and we want to label cloud resources. But also not quite the right fit because they're too narrow. you usually don't deploy every single type of cloud resource, database, cluster, load balancer, in their own stack or deployment unit. You usually bundle them together to form some kind of stack, I will call it here, deployment stack. So that leaves us with a component. And it's actually a perfect fit, because if we think about it, a component has or needs resources, cloud resources. And if we restructure our Terraform code in such a way that every single Terraform stack is defined as this is a component, part of a component. We call this even the component stack. So what we did, we restructured our Terraform code to map to our components. And what about shared infrastructure? For this, we said shared infrastructure acts like a library you would have for software. So we created shared infrastructure components that, again, needed to model to the deployment stack in Terraform. It's a system model. But there's more. There's also Backstage acts as the source of truth, which is very important because you don't want to, again, have multiple sources of truth for your resource labels. That's the problem in the first place, that you usually have to update your metadata in multiple places, and then it gets out of date. It's messy. Don't want that. But for a platform initiative, it's also important that it has an API. And this catalog API can be leveraged to fetch the metadata and apply it to Terraform. So Dave and his team took the API, plugged it into the factory, and then what? Yeah, how do you use the Backstage API in Terraform? First, they looked at integrating it directly in the deployment pipeline. Logical step, there you can send curl requests or use some other form to talk to the API. But soon they realized it doesn't really work, and it's error prone. You can't really map it to each individual deployment unit. So they sat down again in a cafeteria and thought about, okay, how can we do this? And Dave overheard someone on the next table talk about a thing called, they called it the World Wide Web. It's a place so mysterious, you can find answers to everything there. Goosebumps he got. And then he started to actually search the World Wide Web and rolled a net 20. Nice one, Dave. He actually found something. He found the Terraform provider for Backstage, created by Thomas, and Dave immediately fell in love with it. I know Thomas is here somewhere, so big shout out to him. Thank you for creating the provider. All of this, the talk and everything I show you, would not have been possible without Thomas' provider and his great help. But the story continues. So the provider is also super easy to use. It just has a bunch of data resources that map to the catalog API. You give it a component name, and you get back all of the entity metadata. What would you want more? So Dave and his team plugged in the provider and started to roll it out. And it was last year on a November morning. I was sitting in my office and rain was pouring on the windows, and we just rolled out the provider into every single of our stacks. And I was watching a pull request, the log lines, the deployment log lines go through, really waiting, come, this has to be work. And then the planning started of the resources, and labels showed up. It actually labeled every single resource I put in there. So cool. I immediately sent some funny GIFs to my teammates and yeah, it works, awesome. And I opened back up the browser window and log lines scrolled through, one by one, by one. Red ones. Backstage was down. I tested in production, awesome. And I destroyed Backstage because I tested with Backstage. And with this, every single Terraform deployment grinded to a halt, banged against the wall, nothing worked anymore. Because with adding the provider to every single deployment, we just introduced a critical dependency. And you can't fix it now without removing the Backstage part again. So as a quick bandy and patch, we created a static fallback module that could be swapped in place. Luckily, I work early, so it was 5:30 or something, and I swapped in the module and everything started to work again. Wiping the labels clean of the stack, I just witnessed apply. Yeah, and then we sat down together in the cafeteria and started to think of alternatives, or how can we more safely use the Terraform provider for Backstage. More Backstage instances, you can always throw on more. More helps more, right? Yeah, it helps with increasing costs, but not necessarily with the problem. If you kill Backstage in an upgrade, doesn't help you really. Then we started to look more on the provider side of things. We could add retry mechanisms to the provider to have these short failures mitigated and not fail a pipeline just because a call to Backstage returns an error. Or we could add a fallback mechanism that would allow us to provide some kind of fallback data in case an error occurs. And we got in contact with Thomas and his on his GitHub, and it was really awesome to see, because we wrote down this issue, described the problem we had, and within a few hours, Thomas responded and even said, here's a PR, I implemented the retry mechanism. How do you want to do the fallback? And a couple of days later, we was so kind to implement the fallback into the provider, member of my team. And only, I think, the week after, everything was merged, published, and the provider ready to use. Isn't that cool? Open source. Just love it. And we took the provider, and what should we use as a fallback input? We never really thought about it at the point. We just said, hey, we need some fallback. This can't work like this. Well, we could use generic dummy data, but then we're back at the stage of the static fallback module. It would wipe clean all labels we have and create a lot of drift. It's not really nice. We could use static metadata, so users define the fallback data in their stacks, but then we're back to the start, where we have two sources of truth. And in case of a fallback, would also create a lot of drift. Then we came across something interesting. We could use Terraform remote state. Terraform remote state allows us to always fetch the last up-to-date snapshot of the metadata, the last successful set of labels, and the last successful snapshot of the entity, and use that to pass it in to the provider. So this is how it looks like. When applying or planning, Terraform requests the last successful state from Terraform remote state. This you always have, otherwise you can't plan or deploy anyways. The fallback is passed through to the provider, and in case Backstage is down, it just returns the fallback. And since the fallback always matches exactly to 100% what's already on there, you will never get any drift, and Backstage can be down for weeks. I don't know if you want that, but could be down for weeks, and your labels wouldn't drift. It's the perfect solution. So we went back, plugged it into our trusty factory, and started producing some packages with labels on it. And it worked. Worked so good, we even took down Backstage in production again to see how it works, and it works perfectly. No matter if Backstage is up or down, your labels get written, and you have neatly packaged cloud resources. And if the owner changes on your Backstage entity, on the next plan, the labels are updated. At this point, I really want to give a big shout out to my company making this possible, supporting me in this talk and everyone that was involved in the project. Big, big thank you. And I also want to give a big thank you to Thomas for creating the Backstage provider. So now it's tech talk, so there's code. I brought some code as well here. How you can actually use the Terraform provider for Backstage. That's how it looks like. Let's break it down. So I created a Terraform module that simply wraps the provider and provides a standard set of labels. You can use this to create your own module, fork it, copy it, do whatever you want with it, use it. It serves as a blueprint, as a starting point for you. It takes a single input, the name of the entity you want to fetch, optionally also the kind of the entity, namespace, yada yada. It also takes in the Terraform remote state as fallback source. So this is how it looks like for GCP here, but you probably have your own backend. And then, this is the nicest part, and I love this, you get this in every single stack. Imagine how cool it is for your devs to just type module.metadata.labels, plug it in everywhere, and it's always up to date with the metadata from Backstage. You have to never worry again about labels. And the best part, this bulky part down here, we automated with Terramate's code generation. It's an open source tool. They're also here in a booth at KubeCon tomorrow. And we automatically generated and injected all of this into every single stack. So our users didn't even have to do anything. And they all got this. Party time. And now, to summarize, some action items. You should think about how you structure your infrastructure. Can you structure it around Backstage to make it more easily mappable from your metadata catalog? Then you can safely use the Backstage Terraform provider using a remote state, and you can generate and automatically inject this module and the Terraform remote state source into every single stack. There are many more code generation tools out there, your choice. And so that you don't walk away from this talk and forgetting all of this and what module do I need to look up, I created a short resource for you all. It contains 2 blog posts, one highlighting exactly what I just said with some architecture diagrams, and one going really deep into the nuts and bolts of Terramate, and it's a detailed how-to guide, how you can leverage the code generation. At the end, you have exactly this. There's also a link to the provider, the metadata module, and I would highly appreciate if you take the time and rate the talk. There's a link in there as well. Go to 1k5.link/London25, and you can scan this QR code to get all of the resources. And I will be out there for questions, and I have some swag in my bag, so 4 of these cool t-shirts. The first ones to hit me up can grab one. That's it, how you can fix your resource labels. Thank you.
We can take 1 or 2 questions if anybody has any questions. All right.
Okay, yeah. I have one question about detecting the drifts. So do you have any tool in place that is monitoring the resources in real time or sort of near real time?
Question is about how do we detect drift, if you have any tools in place to monitor those. Yes, we actually use Terramate to orchestrate all of our stack deployments, and it also has some nice drift detection built in. They have a cloud feature, a planned cloud feature where you can then get alerts on your drift, and we use that. So we actually get drift alerts if an entity in Backstage changes, because this runs every night. and then we get a fresh alert if you know, hey, we need to apply this. And you could even start automating this with some, for example, dependable style PRs that auto-fix your labels for your stacks.
All right.
Questions?
With that, thank you. Thank you.
Okay.